Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 180. Please turn to page number 180. The second problem on the page, 197. Now listen, here's the deal. Here's the deal. Before we do the problem that you see that in front of you, before we do the problem number 197 that you see in front of you, let's do the following. First of all, I do not know why I have urge to write everything, and secondly, I cannot write. Let's do the following. Here's the thing, listen carefully. You're going to be given a rectangular box that looks like this. A rectangular box that's going to look like this. Voila. There you go. That's your rectangular box there. And the dimensions are 2, this is 2. From here to here is 7, and this thing from here to here, we are told, is 10, which of course is the same as this guy. Here's the question. I'm going to put the question in a different color so you can hopefully you can see it better. This diagonal that you see from here going all the way to here. What is the length of that diagonal? Can you tell me? Can you tell me what is the length of this diagonal? Now here's what I want you to do, which is a very similar question to the one that you see in the book there. Here's what I want you to do. I want you to pause the video at this time. Stop the bloody thing if you have to. I want you to work on this problem. Do not continue watching it unless you have until you have the answer to this question. Because once you have seen the answer, once the solution is done, then it's no fun. There is no point in doing a problem when you already seen it how it's done. So pause the video. Do it yourself, and once you have the answer in front of you, you can resume the video. Alright, go ahead and do that. I'll give you a few seconds just to do pause and unpause. Here's what's going on. The answer to this problem. You're going to hate me for this, but I'm going to send you on a wild goose chase. It's not a wild goose actually. Here's what the answer is. The question simply was, what's the length? I forgot to put the question. What is the length of the diagonal AB? And you will find the answer to this question here. Revised GRE. Revised GRE, Revised GRE Math, day 176. Watch that video if you had trouble getting this answer. Make sure you watch that video, make sure you have the right answer before you continue watching the solution to the problem that you see in the book in front of you. These are very similar questions that will just give you more practice. Alright? Here's the next question. Are you ready for the next one? Here you go. In the next one, they do not give you a picture. There is no picture given here. the problem appeared like this. I'm going to put it on the blackboard. In the next problem, as it appeared in the exam, no picture was given. It simply said that we have a rectangular solid. Rectangular solid, which is actually even more similar than what you have in the book there, because I just realized in the book also, in your exam in GMAT, also there is no picture. It simply says a rectangular box. A rectangular box is the same as a rectangular solid. Is 10 by 10 by 5 is what it says in the book, and the question simply is, what's the greatest possible straight line distance between the 2 points on the box? The greatest possible straight line distance between the 2 points in a rectangular box is the diagonal. This diagonal is the greatest possible straight line distance between any 2 points in a rectangular box. So here we are given a rectangular box which is 8 by 9 by 12, and the question simply was, what is the length of the diagonal AB? Or they didn't say AB, they just said what's the length of the diagonal. The longest diagonal. I don't know how exactly they phrase it, but they're looking for length of the diagonal. Again, I want you to pause the video. I want you to do this problem. Find out the answer to this one. 8 by 9 by 12. Pause the video, do it yourself again. Do not continue. Do not continue watching it. The more practice is better. And the answer to that question, answer to this question, you will again search for this tag. Just type in revised GRE math day 177. I know, I'm fully cognizant of the fact that you are not here for GRE. This is a GMAT course. I know that, but they have some similarity between the two exams. To say nothing of the fact that the math is math. Math does not change. A very similar question similar to what you see there on 197 appeared on the GRE. As you can see, they are very similar. There is no difference. Do you understand? Very good. Now, let's do the problem that is given to us. The problem that is given to us, we are told that we have a rectangular box which is 10 by 10 by 5. What is the greatest possible straight line distance between 2 points on the box? So here we have a box which is 10 by 10 by 10 by 10 by 5. So even though it does not look like, this, well actually it does. Actually, let's say this is 10, this is 10, and this is 5. So that's what we're going to do here. Let's carry. Let's say we're done with this part. Let's solve the problem 197. The very first thing we have to do here, this is how we go about it. The very first we have to do here is the very first thing we need to do is to figure out the length of the bottom diagonal. The bottom diagonal is this guy right here, which I'm going to draw it here. Perhaps even one more color would help if we can. I'm not even sure if you're able to actually tell the difference in the colors, but for whatever it's worth, here's blue color. And the bottom diagonal that we're just describing is the diagonal that's going to be from here, from this point, from the point, from this point, that's the bottom. And the bottom diagonal, the diagonal of the bottom, is this diagonal that we're talking about. How would that help us? Because once we know that diagonal, we know how much from here to here. Let's call this point C. We know how much from B to C is. B to C is, we are told, B to C is 5. B to C is 5. If we can figure out the bottom diagonal A to C, then we should realize that this thing is a 90-degree angle. Okay, one more time. We're going to go very slowly. Once we figure out the bottom diagonal, which is A to C, once we have the bottom diagonal, we know what B to C is. We can very easily figure out A to C by using the Pythagorean theorem one more time. So this, what may look to some people as a fairly complicated problem, is in fact a very straightforward application of Pythagorean theorem, It's just that we have to apply the Pythagorean theorem twice in two parts. So in the first step, we find the bottom diagonal. Once we have the bottom diagonal, we use that information to find the diagonal AB. So let's do that, shall we? The bottom diagonal is made up of, here's what bottom diagonal looks like. Let's give it a name here, A, B, C, let's call it a D. So we're looking at right now, triangle ACD, triangle ACD, which is a right triangle. You have to imagine, use your imagination, even though it does not look like a right angle, this is in fact a right angle. These are two sides of a square, as a matter of fact, because it happens to be 10 by 10. It's a pure chance that it happens to be 10 by 10. It's where the two sides meet in a square. Of course it's 90 degrees. Let's find out, shall we? The triangle that we're looking at is this. A to B, rather A to D is 10, D to C is 10, and what we're trying to figure out is A to C. So we're calling A to C is X. A to C is X. Let's find out. It is X part, which is simply X squared equals 100 plus 100, or X will be square root of 2 times 100, which is simply 10 times root 2. Well, that was it. That was fairly straightforward, fairly painless. So that's it. We have our X. Now we do the rest. Now we look at triangle. I don't want to erase the X. As a matter of fact, I shouldn't have put all these things so liberally. Now we look at triangle. Now we look at triangle ABC. ABC. In triangle ABC, we just found that A to C, which was X, A to C, we just found is 10 root 2. We also know that B to C is 5. B to C is 5. Let's do it on the top, so that we don't have to do way in the bottom here. So A to B, let's call that Y, is simply going to be Y squared equals, this guy is squared, 10 root 2 squared plus 5 squared. 10 root 2 squared, 10 squared is 100, square of square root of 2 is 2, plus 25. So it gives us 225. 225 can be written as, let's see, how can we break up 225? 225 can be written as 9 times 25. And therefore y is going to be square root of 9 times 25. Oh, this is working out to be just fine. 9 times square root of 9 times 25, the square root of 9 is 3, the square root of 25 is 5, voila, y equals 15. The final answer is 15. Final answer is 15. The answer is A. The answer is A. Even though it's not very legible. Well, so that's it. One more time. A recapitulation of what we just talked about. This problem requires two-step process. In the first step, you find the length of the bottom diagonal. The length of the bottom diagonal actually is the hypotenuse of the two sides of the square. Here it happens to be square. It doesn't have to be square. It could have been rectangle. Once we have that side, which is the diagonal of the floor, that diagonal no longer that diagonal, which is the hypotenuse of this triangle here, ADC. Once we go to triangle ABC, it ceases to assume its role as a hypotenuse. It just becomes the base of the triangle ABC, and the hypotenuse is this part, A to B, which is what we are interested in. And we go one more time. Do you understand? I just used the word a little while ago. I want to make sure that you understand it. The word that I used was most of you would know it, obviously. I understand that. I'm fully cognizant of it. For those of you who do not know it, the word was recapitulation. If you do not know what it means, and if you're interested in learning without giving it away, I would like you to go and learn it properly in the vocabulary video. I'm going to quickly give you the date or rather day number where we learned it. Recapitulate. Day number 32. Day 32. Just type in vocabulary, day 32, search for it, along with my name, it should pop right up. Even without my name, I think you will find it. Just type in vocabulary, day 32. Recapitulation, not to be confused with capitulation. The word capitulation, the word capitulate, and recapitulate have absolutely nothing to do with each other. Do you understand? I will see you tomorrow. Another word comes to my mind right now, which I will not use, which is the word that, for those of you who are familiar with what I'm about to say, a word that comes to my mind is the word that Sheldon would use in Big Bang Theory, which sounds a little bit like recapitulate, which is the entirely word also in itself. Not recapitulate, rather, capitulate is the word I was thinking about. Do you understand? I will see you tomorrow, okay? Bye now.